All right, so we're taking a look at the Math Counts team round, or sorry, target round 2017, and this is 3 and 4. I'm probably going to include 5 and 6 on this one as well. And since it is a target round, we can use a calculator, so I'm going to pull that up right now. All right, so here we go. I think these first two are pretty quick. All right, so number 3 is a basic system of equations problem. We're at a high school game. We sell 139 tickets, and we have adult tickets and we have student tickets. So that means the number of adult tickets plus the number of student tickets is going to be 139. I'm going to make this look a little bit better. All right, and so looking at my other equation or other situation, we know we sold a total of 1,576.50, and an adult ticket is $13.50. So the value of all of the adult tickets sold is going to be $13.50 times A, plus the student tickets are $8.50, and times the number of students. And so here's my system of equations. Now, the easiest way to solve a system of equations when both equations are written in standard form, which is what we have, is to use the elimination method, also known as the multiplication and addition method. And for that to work, I need to have opposites. And right now, I don't have any opposites. The opposite of 1 is -1. The opposite of -7 is +7. I have no opposites. And the other thing I want to know is, or I need to keep track of, is I want the number of adult tickets. So I want to get the opposite of 8.5s so that I can cancel out the s's, just have the adults. So to do that, I'm going to multiply this whole equation by -8.5. And that will create the opposite that I need. And I'm going to have to multiply it to everything here. Well, clearly, -8.5 times s is -8.5s. -8.5 times a is -8.5a. And that's going to equal, well, okay, I have my calculator. So I have 139 times 8.5, and that's a negative, right? And so we have a total of -1181.5. And so the cool thing about this is when I add the two equations together, the student tickets are going to go away, because 8.5s minus 8.5s, well, that's 0, that cancels out. So 13.5a minus 8.5a, well, that is just 5a. And then when I subtract 1,181.5 from 1,576.5, I will end up with a meager 395. So divide both sides by 5, divide by 5, and I'll get A. The number of adult tickets is 79. Now, obviously, I could figure out how many student tickets I had, but I don't care about that. It only asked me about the adult tickets. So we have 79 tickets. All right. Problem number 4. A data set of 4 positive integers, hold on a second, so I have 1, 2, 3, 4 positive integers, has a mean of 5, a median of 4, so my median's in between those two numbers, and a mode of 2, so that means I have 2 2's. Well, what is the greatest integer in the set? Well, an integer is a whole number, so, all right, so then this number right here has to be 6, because 4 is halfway in between 2 and 6. And so now I'm going to have to use this mean. Now, if I have 4 numbers and a mean of 5, that means if I add all 4 of these numbers together, I have to get, well, 4 times 5, which is 20. So if I have a total sum of 20, so 2 plus 2 plus 6 plus something equals 20, well, clearly this has to be 10, because 2 plus 2 plus 6 is 10. There's my other 10, and the correct answer is, in fact, 10. All right, that was pretty quick. Let's go on to 5 and 6 and do a third video for the last two, which are a little more complicated. Actually, I don't need to get rid of that. All right, 5 and 6, here we go. No, that's 7 and 8, 5 and 6. All right, so this is another just sort of pain in the butt computation problem. So we have a bundle of $25 bills, and each dollar bill, and the whole thing of 25 $1 bills weighs 0.9 of an ounce. So that means a $1 bill is going to be 0.9 divided by 25. That's the weight of one bill. All right. How many pounds? So we have to convert ounces to pounds, right? And how many ounces are there in a pound? That's right. I'm talking to myself. 16 ounces in 1 pound. So that means for every 1 pound, I need 16 ounces. All right, the last thing is I want to know how much 4,000 bills weigh. So then once I figure out how many pounds, how many pounds a $1 bill is, then I have to multiply that by 4,000. And since everything else is in a fraction, I'm going to write that as a fraction. All right, so let's multiply some stuff together. So we're going to end up with 0.9 over 400, because 16 times 25 is 400. And then we're going to multiply that by 4,000. Now, the cool thing about this is 4,000 and 400, well, I mean, that's easy to reduce, right? So 400 goes into 4,000 10 times. So really, this problem just boils down to 0.9 times 10. 0.9 times 10 is 9 pounds. I don't know. I'd take 4,000 $1 bills and carry around 9 pounds of dollar bills. It's better than 0 pounds of dollar bills. All right. This is where things start to get a little bit interesting. All the elements of a sequence, A, B, C, D, and 6, are positive integers. And A is greater than B. So this is going to be important, because this is telling me that there are going to be multiple solutions, but we only want the solution where A is bigger than B. Each of the last 3 terms is the average of the previous 2 terms. All right. So, well, what does that mean? So that means that C has to be equal to A plus B divided by 2, because that's the average, right? Well, following that logic, D has to equal C plus, B divided by 2. All right. And so then that also means that the number 6 is equal to C plus D divided by 2. Well, so then that means that C plus D has to equal 12. All right, so that's going to be helpful. And remember, I'm going to have to get I just need to have to deal with A's and B's, right? So I need to distill these 3 equations into simply A's and B's. All right, sounds like a lot of substitution, so here we go. I can't help notice that we have a C in this equation. I know what C is equal to. All right, so in that case, D is equal to A plus B over 2 plus B all over 2. So all I did is I took this value here and I substituted in for here. All right, so let's do a little quick maths. So to add fractions, they have to have the same denominator. So that's going to be 2b over 2. So that means I'm going to end up with A plus 3b. And then, okay, so now I have to reconcile these denominators, and we get over 4. All right, so now I know what D is. That's great. I can put it in here. I also know what C is. C is this. All right, so now I'm really in business. So if we have C plus D is equal to 12, C is A plus B over 2, plus D is A plus 3B's divided by 4. That's all equal to 12. All right. So our next step, well, we need to have a common denominator. So we have 2a plus 2b over 4. Just multiply the numerator and the denominator by 2. Plus a plus 3b over 4 is equal to 12. So I'm going to multiply everything by 4. So I get 2a plus 2b plus a plus 3b is equal to 48, because I just multiplied everything by 4 to get rid of the denominator. So I have 3a's plus 5, that is the world's ugliest 5, 5b is equal to 48. All right, so now we're looking for a and b coordinate values that would equal 48. So first thing I know is 48 is divisible by 3. So 48 divided by 3, so that would give us 16. That would mean, so again, 16 times 3 is 48. That means I would have to have 0 b's. And right away I know this is not going to be right, because I know that c is the average of a plus b. It's just not, we can throw that one out right away. So then, all right, so then every time I increase b by 1, that's going to increase, that's going to decrease the what I need for my a's by 15. So what is 48 minus 15? 48 minus 15 is 33. So that would say I would have 11 a's. So 11 times that is 33. So that means I need 15 from this area right here. 5 times, how many times, what multiplied by 5 equals 15? 3. So 11 and 3 works. So let's subtract this by 15, and I get 18. So 3 goes into 18 6 times. So that would leave out 30, looks like 30 more than I need to get. So 5 times 6 is 30. And I can throw this one out because I know that A has to be greater than B. And I know that 16 comma 1 doesn't work either given my limitations. So my A value has to be 11. All right. So I'm going to stop this video and do the last two on its own.